So first off, I want to thank you for the opportunity to chat with you today. I hope to make this time useful and interesting for you. When you take a look at the whole world of data architecture once upon a time was quite simple. It was a matter of defining a few elements to some kind of file structure, and that was it. Today, the world of data architecture has gotten to be much more complex and much more powerful. So I want to talk with you today about where we're at today from a standpoint of data architecture. And in particular, I want to talk to you about something called the data lakehouse. So if you go into the corporation today, what you typically find are three basic types of data: structured data, textual data, and analog IoT data. Now, these three types of data are very different from each other. They are all data, but in terms of having properties and characteristics, they are very different from each other. It's much like places on Earth. On Earth, on this global planet that we have Antarctica, the Sahara Desert, and the Amazon jungle. Now, all three of these places are part of Earth, but all three are very, very different. And that's what we find when we take a look at data architecture and look at the different kinds of data that we have in data architecture. So let's take a look now at the different types of data to make sure we know what it is that we're talking about. The type of data that most people are familiar with is structured data. Structured data consists of things like records and keys and attributes and indexes. Structured data comes from things like bank transactions, point of sale activity, telephone calls, payments made, and so forth and so on. So that's a little bit about what we're talking about when it comes to structured data. Now, I don't know if you ever thought about it, but why is it called structured data? It's called structured data because the structure of each record is the same as the structure of each other record. So for example, if I go into Walmart and make a purchase, Walmart makes a record of the purchase that I made. And then you go into Walmart tomorrow and make another purchase, and Walmart makes a record of that. Now, the structure of the records is exactly the same, but the content of the record is different. So this is what we're talking about when we talk about structured data. Now let's talk about textual data. It turns out that there's a lot of business value tucked away in textual data, and quite frankly, most organizations don't pay much attention to textual data, and that's a shame. And why is it that organizations don't pay much attention to textual data? It's because textual data is very complex. For one thing, there's lots of languages: English, Spanish, Portuguese, French, Mandarin. Another complicating factor is the fact that in terms of language, there's different types of language. There's formal language. That's what a book writer does when he or she writes a book. There's slang. That's what you hear out on the street. There are acronyms. Another complicating factor to text is the fact that text comes in a lot of different forms. There's voice recordings of text. There's written printed text. There's text on the internet. There's text on videos. And where do we find text? Quite frankly, we find it everywhere. We find it in medical records, contracts, on the internet, in call centers, in warranty claims, in email. Text is everywhere. And it's a shame that organizations don't pay much attention to text because there's tremendous business value wrapped up in text. Now, there is technology that is out there that can allow you to take raw text in its raw state and put it into a form of a database that can be analyzed. And that technology is something called textual ETL. Now let's go to the third kind of data that we have, and that is analog IoT data. And what is analog IoT data? It's machine-generated data. You may not be aware of it, but machines around you everywhere are generating data right and left. We have things like drones, electric eyes, temperature gauges, speed recognition, mechanical monitors, telemetry, and there's all kinds of data that's generated by machines. Now, in order to understand the analog data, you need to think for just a second as if you were a surveillance camera. So suppose you are a surveillance camera looking at your parking lot. What do you see? Well, at nighttime, you don't see much because people aren't at work at nighttime. So you see an empty parking lot. And then during the daytime, what do you see? Well, around 8 o'clock in the morning, people start to park their cars. And then at 5 o'clock in the afternoon, people start to leave. So there's not much that's terribly interesting. However, every now and then, somebody has an accident, or every now and then, somebody breaks into one of the cars. And so what you find is the vast majority of the images taken of the parking lot by the surveillance camera are not useful at all, but a small percentage of the images taken by the surveillance camera are really, really interesting. So we see one of the properties of analog IoT data is that there's a tremendous amount of data that has no real business use and a small percentage that has a very high importance and business use. So that's a little bit about structured data, textual data, and analog IoT data. Now, a while back, a vendor, I'm not sure which vendor it is, a vendor came along and said, we need to throw all of this data into something called a data lake. And if we do so, we can have our analysts come along and start to use this data whenever they want to. I ran across an organization the other day that had 6 petabytes of data in their data lake environment. Now, what happens is people quickly find out that the data lake turns into a swamp or a sewer. What happens is organizations find out that they can't use the data in the data lake. They can't find any data. They can't merge and connect any data together. And what happens is the data lake turns into a very unuseful place. And so organization after organization wakes up and says, I've got a data swamp here. Help me. What can I do? Well, what you need to do is to turn that data lake into a data lakehouse. Now, the words data lake and data lakehouse sound the same, but as we're going to see, they're not the same thing at all. So what do we need to do to turn a data lake into something useful? Well, there's really 2 things that we need to do. One of them is we need to create an analytical infrastructure, and we'll talk about that. And the second thing we need to do is make sure that the data that's loaded into the data lake is integrated, transformed, and vetted. If we don't make these changes, then and we just throw data into the data lake, then we end up having a big mess on our hands. So what we need to do then is we need to take our data lake and transform it into a data lakehouse in order to turn it into something useful to our corporation. Now, who is this important to? Well, it's important to a lot of people, but perhaps the community that it's the most useful to is the data scientist. I can't tell you how many times I've talked to data scientists telling me, you go to school, you learn all of this wonderful statistical information, you go to the real world, become a data scientist, and 95% of the job of the data scientist is becoming a data garbage man. That data scientists, if they have to operate on a data lake, are not in a position to do data science. They are in a position of having to wrangle and hassle with and clean up and understand data. So they take all of this education and it is not useful in the real world. So what do we need to do to make the data scientist an effective person? What we need to do is, the first thing we need to do is create an analytical infrastructure. So let's talk about this analytical infrastructure. The best way I can describe the analytical infrastructure is like a library. In many regards, pardon me. In many regards, the data lake is like a library. So what do you do when you want to find a book in the library? How do you do it? Do you go into the library and start searching from stack to stack? And the answer is, if you do, you are likely to be in the library a long, long time. Instead, what you do is you go to the card catalog for the library, and in the card catalog, then you find the book or books that you want. And in the card catalog, you'll find a reference as to where to find the book. So you need the card catalog in order to tell you what the contents of the library are. And in the same vein, you need the analytical infrastructure to tell you what the contents of the data lake are. So the data scientist needs his or her card catalog, which is really the analytical infrastructure. And once we have that, then the data scientist can start to become a productive person. Unless this happens, the data scientist cannot become a constructive person or an efficient person looking at the data in the corporation. So what does this analytical infrastructure look like? What the analytical infrastructure looks like is something that's rather complicated. And the reason why it's complicated is the fact that the analytical infrastructure serves three different kinds of data. It serves transaction-based data, that is structured data. It serves textual data, and it serves analog data. And it turns out that the metadata that's necessary to serve these communities is quite different. The metadata that's useful to understand transaction data is quite different from the metadata used to understand text. And the metadata that's used to understand text is quite different from the metadata that is used to understand analog data. And yet all of these different kinds of metadata belong in the infrastructure. So let's say just a few words about the kinds of metadata that you need to find in your analytical infrastructure. For transaction-based data, you need things like a data model, you need things like an entity relationship diagram, you need things like DDL that describes the data. When it comes to textual data, you need ontologies, taxonomies, and something called inline contextualization. For analog IoT data, you need something called distillation. And so you have three very different kinds of needs that need to be brought together into the analytical infrastructure in order to make sense of the data lake, to turn the data lake from a data lake swamp into a useful data lake house. So that's the first thing that you need, the analytical infrastructure. Now let's talk about the other thing that you need. In addition to having the analytical infrastructure, which helps you find the data in your data lake, you need to be able to make sure that the data that goes into the data lake is integrated, transformed, and vetted. It doesn't do you a lot of good just to throw raw data into the data lake. That's a waste of time and money. So what do we need to do? When it comes to structured data, we need to use classical ETL, extract, transform, load technology. And that's the technology that allows us to transform the different applications that we have for structured data and turn it into useful, meaningful data in the data lake. And it turns out that if all we were doing is putting structured data into the data lake, then at that point in time, the data lake is very similar to a data warehouse. But the second kind of data that we have needs something different. This is where textual ETL comes into play. And this is where we take raw text and put it into the data lake. And this is where we take raw text and find the context of the text, find out the text that's meaningful, and put it into the data lake environment. The third thing that we need to do for our analog data is to take data and distill the data. We don't want to take all that massive amount of analog data and put it into our data lake. First off, it's not useful. Second off, it gets in the way. What we want to do is take our analog data and turn our analog data into useful data by finding out what data is useful, and that's what we put into our data lake. The rest of the data that's analog data that isn't useful never finds its way into our data lake. Now, most of you have probably never heard of textual ETL. I'll just say a quick word about it. There's three elements that go into textual ETL: the raw text, such as medical records, internet data, email, insurance claims, etc., and so forth. And it's passed against some things called ontologies and taxonomies and inline contextualization, and the data comes out in the format of a database. The analog data goes through a distillation process. And so what does the distillation process do for us? The distillation process comes along and separates the data into data that is likely to be of importance versus data that is not likely to be of importance. And so this is what the distillation process looks like. And it's what you have to do to your analog data. Pardon me. As we said before, think about a surveillance camera and about which images from the surveillance camera are important and which are not. We had a robbery at 6:31 a.m. on Tuesday, and we had 3.5 minutes of interesting information. We had an accident at 5:15 p.m. on a Thursday, and we had 1 minute of information that was useful. The rest of the images taken by the surveillance camera are in fact not useful. Now, as a data architect, when we start to consider these three kinds of data, we need to take into consideration the relative volumes of data that you find in each sector. That when we take a look at structured data, we find, relatively speaking, a little amount of data there, because there's almost always a lot more textual data than there is structured data. And when it comes to analog data, there's a lot more analog data than there is textual data. So as a data architect, you need to keep in mind that this is what you're dealing with. Now, along that line, we have highlighted in red here the data that has business value. Most, not all, of structured data has business value. Some of textual data has business value, and very little of analog data has business value. And it's that data that has business value that we want to put into our data lakehouse so that people can do the work that they need to do analytically. The rest of the data that doesn't doesn't have great business value, we either throw it away or put it off into bulk storage. Now, you say, gee, Bill, I'm going to be throwing away data that might have some value. And if data is tucked away in bulk storage, you can always go back and scan bulk storage and put the data that you're looking for into your data lakehouse environment. Now, I want to alert you to the fact that scanning bulk storage and doing analytical processing is usually a very slow, cumbersome, and awkward process. So it's not something you want to do very often, but can it be done? Yes, of course, it can be done. And by the same token, you want to, on occasion, take your high performance storage, your data lakehouse, and archive data. You see, what happens is over time, data loses its propensity for being valuable to the corporation. And at some point in time, as data gets to be old, it has little or no value. And when it has little or no value, we want to archive it out of our data lake environment. So what happens when we do this? We end up having a data lakehouse in which data in the lakehouse is fresh, available, not hiding behind huge amounts of data, likely to be used in analysis, constantly being refreshed, and the data scientists and other people can find the data easily. So this then is a very high-level diagram of what you need to do to convert your data lake into a data lakehouse. And I'd like to make a comment here. Is this something that, number one, is fast and easy? No, this is not. This is an ongoing task, and number one. And number two, it's complex. So if anybody comes along and tells you that this is easy to do, they haven't done it before, because this is not something that is done overnight. I don't know any organization that can possibly do this in a short amount of time. Now, people don't like to do difficult, complex things, but that's what's required to turn your data lake into a data lakehouse. Now, one of the questions I typically get when I'm doing this presentation is people say, gee, Bill, isn't a data lakehouse the same thing as a data warehouse? They sound the same, but they're not the same thing at all. Let me try to make an analogy for you. Suppose you have two cousins in the same family sitting in the same room, a young man and a young lady, and they're sitting there. When you look at them, you notice something. You notice that they have similar facial features in terms of their body type, in terms of their facial features, in terms of the color of the hair. It's very obvious that these two children are related. And yet, if you get into the DNA of the children, you find out that even though they do share some genes, there's a lot of genes they have that are different from each other. And that's the same thing with a data lake and a data warehouse. A data lake is something that is similar to a data warehouse, but it's not the same thing at all. From a DNA standpoint, there is a difference. So if you want to turn your organization into a productive, useful organization, take your data lakes and turn it into a data lakehouse. Now, there are some things, and these things are free. I'd like to call your attention to it. There is a book on textual analytics that's free. All you have to do is go to the website mentioned below and tell us where to send it to, and over the internet, you will get a copy of it. And so this is something that I want to call to your attention. In addition, it's also for free. We have a prototype data architecture. So if you want to compare your data architecture to what we think a data architecture ought to look like, you can go to the same website and get this schematic for what a data architecture ought to look like. And you can compare it to what we have shown here. And if you're interested, we'll even happy to discuss it with you. And then finally, I'd like to call your attention to some books that are out there. If you're interested in data lakehouse architecture, you can go to Amazon.com, and there are two new books that are out there, the data lakehouse architecture and the book on the data lakehouse. The book on data lakehouse architecture is a book that describes the overall architecture. The book on the right-hand side describes the internal components of the architecture as well. And so I want to call these to your attention. So with that, we're going to call it a day. I want to say thank you for your time and attention. I hope you found this presentation on data architecture to be a worthwhile thing, and I hope you found it to be interesting. I find it interesting. I work with this every day. With that, I want to say thank you.
Okay, thank you, Bill, for your information. I think there is a question in chat.
Okay. The distillation algorithm is complex. The way it normally works is people define thresholds. They say if a measurement is outside of the boundaries of the threshold, that's when we put it into our data lakehouse. But there are other ways to do the distillation. Another way to do the distillation is to do it by time boxing, saying that it's normal that there should be interesting things happen between 9 o'clock in the morning and 10 o'clock in the morning. And that's another way to do it. Another way to do it is look for characteristics of the data. Now, how do the police do it? The police do it a hard way. Suppose you are a policeman and you have hours and hours of videotape to look at. You're pretty much stuck with sitting there and having to watch hour after hour. And if you can imagine a job like that, after a while, your eyeballs get sore. I mean, you're watching an empty parking lot hour after hour, and so that's how the police do it. That's the hard way. So you can do it manually. You can do it through defining thresholds. You can do it for looking for characteristics of data, and you can do it by time boxing. Those are the ways it's done today. I think that in the future, we're going to be smarter about how we can do distillation, but that's the way it's done today.
So any more questions? Okay. Thank you, Bill, for this nice talk. We're gonna have that one in the YouTube channel.
Okay.
And I appreciate you and audience to be part of today's talk. And we wanna host in more events. We like to do in-person events soon. We will start those. Then hopefully see it in person if you ever come to San Francisco. We like to schedule an in-person event.
Thank you. I appreciate that.
Thank you for your time. Thank you for everyone's time.
Thank you. Thank you.